I have to separate all the x terms with dx, and I have to separate all the u terms with du. So here if you see this part here, we don't want this part. Okay, here we want du because all the u terms are here, and here we don't want sin u with du. Okay, so what I am going to do, first I will divide our entire equation by x. So if I divide my entire equation by x, so here also it will be divided by x and 0 by x. So this x and this x will get cancelled and 0 by x will be 0. So my new equation will become sin u upon x plus sin u plus u cos u upon u into du by dx, because this x gets cancelled because we have divided by x. So in this equation I only want du term. So what I am going to do, I am going to multiply. I have to get rid of this dx term, so I will multiply this, the whole equation, by dx. So dx into this and dx into this term. So this dx and dx will also get cancelled, and 0 into dx is again 0. So now equation becomes dx upon x, sin u will remain as it is, plus sin u plus u cos u upon u into du equal to 0. So we have achieved all u terms and du terms together. At the same time, we also want x and dx terms together. So we have x and dx, but again here we have sin u, and we don't want this sin u, so we are going to divide this equation by sin u. So divide this equation by sin u. So this sin u and this sin u will get cancelled, and now our equation will become dx upon x plus sin u plus u cos u upon, if I take this here, it will be u sin u into du equal to 0. If you observe this equation, we have all the x and dx terms together and all the u and du terms together. So now we can integrate this to find the solution. So now we are going to integrate this equation. So it will be dx, integration of dx upon x plus integration of sin u plus u cos u upon u sin u du equal to some constant. Earlier it was 0 here. Because we are taking integration, we take integration on the both side, and integration of 0 is constant. So what is integration of this part? Integration of this part, that is integration of 1 upon x, is log of x. Now consider this integration. If you see, this integration is nothing but is of the form f dash of u upon f of u, and whenever we have integration of this type, it is log of f of u. In our case, f of u is u sin u. If I take the derivative, it is nothing but u into v rule. So we take first derivative of u, so derivative of u is 1, and we keep sin u as it is, plus we will keep u as it is and we take the derivative of sin u, which is cos u. So this is nothing but sin u plus u cos u, which is the numerator of this term. So as you can see, this equation is of the form f dash of u upon f of u, and this integration will be log of f of u. In our case, f of u is u sin u equal to some constant. So as always I have said, the last integration will be some property, or it will be some simple integration like this. Okay, so this is log of x plus log of this. We know that the property of log of a plus log of b is nothing but log of a into b. So we are going to apply this property. So log of x into u sin u equal to some constant. But as you can see, our given question was only in terms of y and x, but here we have x, also we have u terms. So whatever we substitute in our equation, like we have substituted here u equal to y by x, we are going to resubstitute that substitution. So we are going to substitute u equal to y by x again, that is, this step is resubstituting whatever we have substituted earlier. So log of x into, we have substituted u as y by x into sine of y by x equal to some constant. So this x and this x will get cancelled, and our final equation will be log of y sine y by x equal to some constant. This can be the final solution. If we take log on the right hand side, it will become y sine y by x equal to e raised to c. E raised to some constant will be some another constant k, so this will be equal to k. And this is the solution of this problem, and this is how we solve the problem on substitution. More such problems we will see in our next video, so stay tuned for our future lectures.